then check whether we're getting sound through the capture device. We're not. Why are we not getting anything through the capture device? Let's just... Oh no, that's input capture. No, I want output capture. Excuse me, I'm wittering about the sound system, and I've only just realised that I'm actually wittering about the sound system audibly. That's better. Maybe I was just being a stoat anyway. Right. I thought last time when I listened to the stream back that we had the wrong... that we weren't getting the music through the stream, which was kind of... through the correct route to the stream, which was kind of weird. Anyway, welcome back to Avalon City, where in Shenzhen IO I am building things to move things. Specifically building things to move containers around following instructions. And I'm also sorting out moving IRC onto my spare laptop, which will take about 10 more seconds. And then we'll actually start doing things. So there's like... a few seconds there where people can say things in IRC and I can't see them. Right, so welcome back to Avalon City, where we were constructing things. Oh yes, and while I was away, I have done a bit of work on our attempt at building a game, or rather our successful attempt at building a game. And it now has a couple of features that I've improved on and enough space to put a to-do list on it. So there was a really stupid bug that I discovered, which was if you failed, it would reset the count of how many lights you had to do and start the game from the beginning without re-randomising the light sequence.
That did occur to me just the other day that I didn't remember anything that did that, and I thought maybe there just wasn't wrong.
Well, that actually turned out to be quite easy. You may remember that we had this track here that the random number generator, or rather the sequence generator, used to signal to the rest of the game that it was ready. And then I realised once we'd fixed the sequence generator to take a known amount of time, we didn't need that. And we could just sleep for one time unit at the start. So I reused that signal to go in the other direction as a please rerun randomisation signal. And essentially that just involved adding into the little loop at the end where the randomizer just slept for a time unit repeatedly. It now sleeps for a time unit repeatedly and checks occasionally to see whether it needs to be re-randomize things instead. So that was quite simple. I fixed the lights don't go out when it repeats the button, when it repeats a colour. So there's now here, rather than sleep 10 here, we have sleep 9, move 0, sleep 1. So we push welcome Claire. We push a 0 out briefly, which causes the light to go out briefly. And I've rearranged things so that we use the posh sound card rather than the cheap beeper. Which basically I took this track, which used to loop round, I can't remember quite how, somewhere. There was a track that looped around up here somewhere, and I've rerouted it down here, which gave us enough space to stick that FM blaster in there and also to put out some to-do lists. So now when you lose... So have we got a repeat? Yeah, so there's a repeat. Very slight dimming. And it goes bong rather than beep. It was a slightly inaudible bong. Maybe I need to raise the pitch a bit. Good. So that's the things that I've successfully done. My my to-do list suggests that, well, obviously what I had forgotten was that the buttons are all meant to go beep. So that should obviously be implemented now that we have a thing that can play different tones. I may possibly have spent like about 2 hours trying to work out what the tones should be. Yes, Wikipedia is slightly wrong about this. there are at least 2 different scales that Simons use. Oh yes, I fixed another bug, which is that the colours were in the wrong order.
What tetratomic scale is?
Yes, it's a bugle scale canonically. It should be. I think the most plausible one that it should be is just GCEG. But it appears that at least some Simons have been made with a minor triad instead of a major triad. In all cases, they're really simple ratios of frequency. So obviously, strictly, it shouldn't be using something with equal temperament, which the FM Blaster chip is documented as having. They actually mention, yes, that it's
I think the third,
an equal-tempered
the third of the major scales
skill.
has got particularly bad representation in equal temperament if what you wanted was the really simple ratio.
Yes. So yes, we'll have to make do with that. Oh, amusing thing, though they don't actually mention it. The FM Blaster actually takes MIDI note values in a shocking bit of actually following real-world standards. Nothing else in this world follows the same standards as the real world, but MIDI note values.
That reminds me, speaking of random hardware stuff, I was having a conversation at work recently about like 8-bit microcontrollers and the practice of having a 16-bit address bus, a 16-bit data bus coming out of your CPU, and if you only got ROMs with 8-bit data buses, you send half the data bits to each ROM, and that way you can, and then you just point the same address at both ROMs and get 16 bits in at a time. And I was wondering, could you do that in here? You could point the address line.
Yes. You'd better not try to. Well, yes, I'm not. I haven't tested what would happen if you read from the address bus, but I think you can perfectly well write. No, I'm not sure you can. But happily.
Well, you wouldn't be, I mean, only the CPU would be writing to the address bus.
Yes.
It's just the address bus.
Conveniently, I have a.
You'd be going to 2 separate ROMs, and then you can.
Maybe I should make a more sensible scratch pad, but. I just keep putting experiments on this board. At some point, it's going to run out of space. Like actually, maybe now. Oh no, I can do this. No, that's not right. Yeah, you come down here. So if we do that. Does that set both things? Because I have a horrible feeling that that what will happen actually is one of the 2 ROMs will receive the data. Nope. Okay, it does work properly. Oh, hang on. I'm repeatedly sending it. Let's fix that as well. Of course, you can't sleep for 1,000 time units. You can sleep for 999 time units.
The address and data ports on this not the same. I've forgotten how this works.
Well, the ROMs have each have 2 address ports and 2 data ports. But
So I was thinking, you send an address and it goes into both address ports and then you read from the data ports.
yes. Well, I haven't bothered wiring up the data ports because I don't care about the data. The data's all zeros anyway.
Well,
Right. No, if you send it once, it gets read by one of the ROMs.
oh, that's it. Right.
Okay, let's. So but maybe it's consistent. I can tell you a few of the other things I've discovered. So it sends one which goes to there. No, it's non-deterministic, sadly.
Awkward.
So you can't use that trick because of the general rule that XBus has for any given packet one transmitter and one receiver. If several things are trying to receive, then one of them will be chosen. If precisely one thing is trying to receive, then it will go to that one thing. I think our Simon game uses that. Yes. So other things I have discovered while playing with this are simple outputs are wired OR, and actually wired maximum in that if you use them in analog mode, you will get a reader will, as far as I can see, reliably see the maximum of all the values. Yeah, okay. I haven't. I don't. I think simple outputs are actually 0 to 100, so I think they aren't signed. Otherwise, yes, it would probably turn out to be furthest from 0. But
that sounds well. Then you would have tried it.
And the programmable logic device, I've worked out how the feedback circuit works. Yes. So you can see it's highlighting some of the wires, which are the ones which are high. So each input controls one of these, lights up one or other of the rows depending on whether it's high or low. And then if you have a fuse set there, that then highlights one of the columns. This is then an AND gate which ANDs all of the things wired onto that column. And then you have the same thing at 90 degrees there going into an OR gate, and then each of these outputs by default comes from one of those OR gates. Two of them are also wired to this flip-flop as set and reset inputs, and then that allows you to either get this output from that row of OR gates or to get it from the output of the flip-flop. So in particular, what I think I've built here is... Where have I not built it anymore? Maybe I've taken it apart again. I think I've fiddled with it too often and it no longer works. But you can... Oh, I can't remember. But there was... I think at one point you can at least build a divide by 2 counter here, which is interesting. Yes, and the RGB LED is not very helpful in that it just lights up the different segments in RG and B. So it doesn't actually give you colours. And this bit doesn't work because...
If you stand a really long way from the telly, you'll be
Yes.
the wrong end of the telescope. Meanwhile, Claire is trying to interject K-pop into this.
Right, okay. Right, I should actually... Hang on, I that's on the wrong laptop. I'll look at it later. Of course, I'm not on IRC. Maybe I can't. Oh, stoats. Anyway, so yes, we've discovered that you can't actually do the silly trick of paralleling the address bus of ROMs. Yes, the Archimedes did that, but of course it has a 32-bit data bus. And so the Archimedes operating system is spread across 4 ROMs connected in parallel to the address bus. So yes, what else was I doing? Yes, so I know what notes I want. So the buttons should play sounds. When you press the wrong button, you should not get the sound for that button. Instead, it should go bong, and ideally should light up that light for longer than usual. Oh, it's Blackpink again. There are other K-pop groups, Leo. It would be much more fun if you did one of the cute ones. Or, you could have some fun with G-Friend, actually. Yes, it should eventually time out waiting for a button to be pressed and go bong and fail you. Ideally, there should be a start button, or possibly modern Simons actually use the green light as the green button as the start button in order to save on buttons. So if we're imitating a modern one, it should flash the green LED at startup, and then is a signal that we need to press the green button to start. And ideally, I feel that buttons should actually be in the corners of the device with all the circuitry in the middle. That might be quite tricky to achieve, though. So that's my to-do list, and I'm now going to ignore this problem because I'm going to try to solve the puzzle we're actually working on. Oh, yes, I had another thing to say, didn't I? Let's get back to our proper puzzle, and then I will mention things. So, yes, what we are actually working on is a thing that moves containers around. And, I got to the point where it can break things like So now I have to remember. I should have left myself a note telling me what worked and what didn't. So as I recall, something like everything on the right-hand half of the board is working correctly, and everything on the left-hand half of the board is as yet not right. The things are indeed containers, in that it will by default pick up a container repeatedly, trying to move it to the right to the first slot, and thus destroy things horribly when it does so. So it looks like we have that thing which takes a number and moves right by that much, or left by that much, depending on whether you give it a positive or negative number, right? And this thing which handles picking up and putting down, and then this thing receives some signals over X bus to tell it what to do. So it gets sent to 0, which causes it to pick a thing up, and then a 1 which says to put down in slot 1. No, it's more, it sends 0 and -1 and 1. Right, yes, and indeed if we look at this, all that this does is send 0, wait for a reply, send 1, wait for a reply, send 0, send -1. Right, okay. So obviously that needs to be rewritten. What do we actually receive from the radio? We receive a packet that begins with 1 or 2, and 1 says store this item in the first available storage bay, and 2 says fetch this item from a storage bay. So that means that we need, so I feel that this probably wants 2 processors for this bit. We need something that handles remembering, and something that does fetch from, deliver to this storage bay or fetch from that storage bay. So I mean, admittedly, the things are getting fairly tight here. So I think this one is going to have the rule that it accepts a 1 or a 2, probably, and then a storage bay number, and either delivers to or collects from that storage bay. So we'll do something like teak SLXX0. Wait for a message. Check if what we got is a 1. If it's a 1, we want to place something in the location given by the next instruction. So we want to issue a I really want a subroutine call here, but that's really hard to do in this processor. basically, I think if you want a subroutine, you do it by having a spare processor do it for you. But that, yeah, maybe we can actually. Then, in any case, we save the destination, because we're going to need it to move back again. Move the arm to the right. We're going to have too many instructions here. Maybe we do need but see, the problem is that there's all of this waiting around for things to happen, and that takes time, and that takes an excessive number of instructions. So then we always pick up or drop. And then the problem is we still need to move back and drop again. And the annoying thing is that because each of these operations is the thing we have to wait for, we end up with this SLX-X3 MOV-X3 null after every damned instruction. I mean, I appreciate that this is a really stupid idea, but maybe we just write the entire instruction sequence into a RAM chip just to provide some buffering so that we don't have to sit here sleeping every instruction. Instruction is the wrong word, command, shall I say, because instructions are obviously things that happen inside processors. So we could instead have this thing, rather than doing a thing and signalling back, just read a sequence of commands from a RAM chip and execute them and just signal back when it's done. The only awkwardness is a slight shortage of X-bus ports. Probably not so much of a shortage as to be a problem, actually. So if we imagine instead sticking a RAM there. Now the problem is we do actually need something to be able to get to the address pin on the right to be able to reset it. So if we imagine this instead let's just dispose of that one for now. Oh yes, on the subject of the background music, a thing I was going to mention is that I discovered it's all available on Bandcamp.
Yes.
Which will not cheer Verity up at all. Zachtronics.bandcamp.com has all their soundtracks, and today is Bandcamp Friday, where Bandcamp waive their portion of the fees and pass all of the price, well, all of the price apart from the payment processors bit, onto
Yes, thanks.
Zachtronics' composer.
Zachtronics' thing, because I don't actually have broken this off now.
Sorry. Right, so Yeah. Excuse me, that's not where that's meant to go. I mean, actually, I could route that one underneath the chip, which would save on space, couldn't I? Right, so then the idea, make that listen on X2 instead, is that this writes, does something like mov naught x1 mov naught x3, reset both the input and output. Oh, I wonder if we could actually have these share a data port on the RAM if we timed things correctly. Think about that later. So then we want to write to x0. So we just do, rather than doing all of that, we can just write these straight out to x0. Okay, no, we need to use the accumulator because we need to negate things.
I'll go straight for
Right. Oh, we do also need a way to signal to the next chip that we want it to do something, don't we? Okay, let's do the stupid thing that I thought of then. Actually, can we do this? Let's use the left-hand pins because they're easier to get to. Kind of. So the idea here is that this processor will be waiting for a signal from this one to do things. That doesn't work. Because this one's only going to signal back when it's done everything. So we'll have to keep track of how many instructions it's got to run. Which is kind of alright. Except we don't have much space left. Like none at all. Maybe this is still fundamentally incorrectly designed. The annoying thing is that this is using this doesn't actually do anything in ACK that couldn't be done in DAT. So let's move it to DAT. Then we could move. Then we could have this do the counting, and actually every sequence of instructions is precisely 4 instructions. Every sequence of commands is precisely 4 commands long. It's move right, do a thing, move. It's either do a thing, move right, do a thing, move left, or it's move right, do a thing, move left, do a thing. Which means that we can perfectly well say add 1 teak ac 4 if it is 4 mov 0 ac add mov null x0, which should actually now be x1. So that will now, this processor now waits for a command, waits for a signal on X1 on this X bus. When it gets that, reads eventually 4 bytes from the RAM and executes those and then signals back on the X bus. So then what this one does is it waits for a signal on X1. If it's a 1, then it constructs a whatever it is. Let's put these commands in a slightly more sensible order. Which is the address pin. The address pin is X0. So let's put that there. Right. So it, on receiving a 1, it will first insert a pickup command, and then it will insert a move command. Then it will insert a pickup or drop command, whichever it happens to be. Then it inserts another move command. Then it optionally inserts a drop command. Then it needs to rewind. You seem to have some disagreement about which port it should be writing to. Its outputs should go to X3.
You can leave it on the table if you want.
Right.
You can leave it on the table if you want. Okay.
So then that now writes the correct stuff. Then it needs to go send an arbitrary signal down X2, wait for X2, consume the value thus produced, loop back to the beginning. The only slight problem is it never actually signals that this is complete. But here's my overly optimistic viewpoint. We never do anything on completion of moving a container. So obviously someone is supplying our containers slowly enough that we're guaranteed to be able to process them in time. Therefore, we don't need to tell anyone we finished moving each container. Right, good. I think I should probably like untangle these a bit. Anyway, so that if we now insert something that, for instance, does mov 1 x1 mov 2 x1 something like that, that should cause it to repeatedly move things to and from position 2. Okay, something's not working. Okay, there's my first problem. That... Oh no, that's correct. Why are you writing... Oh yes. Why are you reading from x2 there? That's rubbish. That should have been a read from x1 as well. Okay, closer. So we have correctly programmed the RAM. Then we send a signal asking for a move. Then that thing goes back to the top and SLX is on X1 again, which is not helpful. So it should only do that right at the start of the program, and if we're in this loop. So that may mean we need to work out how to make this slightly shorter in order to fit this all in, which is going to be a nuisance. I mean, we could have it able to see the address bus, but it doesn't have any spare pins for that. I mean, what we would like here is just a minus jump about here. Here, actually. We haven't got space. I mean, that would be a particularly stupid plan. I wonder if... No, we can't do that. I was wondering about having... about wiring the... wiring something to two different XBus ports on the same processor, because that way we wouldn't have to... Oh, hang on, no, there's an obvious thing we can do here to make this simpler, which is that we know how long while this one is kind of an inconvenient thing to deal with, though maybe we can actually do that. Here we know precisely how long we know precisely how long a grab operation takes. It takes 2 time units. Got 1 time unit there, 1 time unit there. Gen and a slup. Therefore we can replace SLX X2 MOV X2 null with slup 2. Then of course we need to stop this one bothering to send a signal back, but that's fine. Right, that now gives us one spare instruction, which we can use for an inner loop, which starts there. Now we don't actually need to conditionalize those. Right, so now that looked pretty good in that it picked the thing up and put it back again, and then everything was disastrous. So that means that this thing is able to send useful signals. Good. I think I may need to work out how to cram things a bit closer together. Stick that note out of the way up there. Yes, we can of course fairly easily predict how long we have to sleep here as well, but it kind of involves gratuitously negating things again because I went and made my protocol really silly. So let's not try to do that yet. So I think I want to reorganize things a bit to try to fit in ideally another big processor and some RAM. So that's probably going to involve reorganizing the pins on several processors. Because we can stick this one, oops, here, and then stick the RAM somewhere, but we need to be a bit careful because X1, because what we actually want to wire to the RAM is X3 and X1. Okay, no, that's kind of awkward. Okay, can we move this one down by one? Not easily, because then that track becomes inconvenient. Unless we move this down by one, but then that track becomes inconvenient. So maybe I want to put that RAM about there. That bit's fine. Then we could swap X1 and X0 and do that. And then X0 becomes the input. And then that gives us a nice big space over here to stick another processor and a quantity of RAM for that processor's private use. Right. The only slight problem is that we want to connect things to X0, which we can't do if that thing is sticking out there. Right, so what does it, so if we just prove that still works. Good. Right. So then we need something that receives from the radio, works out whether it's a move right, a move left, or a do nothing, and depending on which it is, looks up, either looks up in the RAM where the relevant container is, or finds an empty slot in the RAM and sticks the container in there. gods, do I need another process to be the like storage management subroutine? So we have a processor that you send either you send it two numbers, which are what it's looking for and what it should do put there when it finds it, and it looks for the first number and swaps the second number into the RAM in place of the first number, and then tells you which cell it found it in. And that seems like a reasonably simple protocol that we can stick, because it was the thing I just realised. There's no way you can implement a return instruction in this processor, because it basically has no computed jumps. But that means that if you want to have a subroutine, the best way to do it is to spin it off into its own hardware.
Yes. I've always said that one of the criteria for deciding where to put an interface between two pieces of code is what I think of the orange segment model, where you minimise the flow of juice across the interface. And this game really seems to subject you to that with a vengeance, that most of the difficulty, because of the processor is so small, is to break up the whole task into things that will fit in one frame of reach and have minimal data flow between them.
Well, because you can't fit any logic handling it within the processor. So,
I mean, presumably sooner or later there's going to have to be something where you end up just writing a bytecode interpreter and filling a bunch of rounds with something properties.
If you can come up with a good bytecode interpreter in whatever it is, 14 lines, fewer than that, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14 lines, yes.
Between the RAM and the maths code processor.
Oh, I worked out what the math coprocessor is for.
Oh,
It's a non-blocking XBus buffer. Because one of its commands is set. And it has 4 ports. And whenever you read from any of the ports, you get a copy of whatever's currently in its result register. So anything connected to any of its ports can change the contents of the result register, and then anything connected to any other port can read that whenever it wants, repeatedly.
And the fact that it can also do maths is a minor detail that's really useful.
But the thing the game really lacks is a non-blocking XBus buffer. Like most of the maths it can do, you can do in the processor anyway with fewer instructions than copying it out to the coprocessor and reading it back again.
Yeah.
I mean, not all of them, but... So now we then do something like mov naught. I may not be able to fit this into this little processor, but we'll see. Check whether data is equal to the accumulator. If not, jump back. Really is a very tight loop. So then we have, oh gods, I may not have enough registers for this. Though that may just involve changing the protocol, of course.
that's nice, dear. What?
Which, if you read further on, this is actually evil sequential homology. And then you have a
Right,
it's
so
so that seems to be what they're really after.
right. So I think that processor implements the protocol I just described. Let's see if we can explain it. So it first two are boring. It waits for a request on X0. It doesn't even make quite the protocol I described because I've changed the order in which things happen, and I'm just hope that the other end of the protocol can cope with this. So it waits for an input on X0. On X0, it expects to read a number that it's looking for in the RAM. It saves that in the accumulator, resets the RAM pointer to 0, repeatedly reads RAM data until it's equal to the accumulator. At this point, the RAM address pointer is pointing one beyond the cell that contained the interesting data, but that's fine because our container bays are 1 based and our RAM is 0 based. So we move write the current address back to. What are you doing, Harris? Yes. Oh damn! I'm one instruction short. We read the current address into the accumulator, send the accumulator to the customer, subtract 1, and then annoyingly we need to write that back to the address bus in order to step the RAM back to point to the thing we want it to point to. Right. Because the thing is that in order to overwrite a cell of RAM, we need to read it, move back one element, and then write it again. And that needs the accumulator. I don't want to have to use a big processor. I'm running out of circuit board space. Because otherwise, this is precisely what I want. It's just one instruction too long. Not easily, because then I need to get a track out of it to the left. I mean, it need not be to the left. I can shuffle everything around. I could, but I don't really have room down here to stick the radio and another processor. I mean, I can put things in different places. It would be nice if I could just throw out one instruction. I mean, I've already done something slightly weird to the protocol in the hope that we send back the what cell we found the thing in before we overwrite it. I mean, that would be really horrid. I don't really want to make the protocol more complicated than it needs to be, but the radio receiver may actually be a fairly simple job. So, I mean, maybe we just make this a big one for now and then hope that we have space to do everything else. Don't know if I want to yet. Okay, I can't actually wire anything to X0 if I put that there. So if we put it there, then I can. So then the idea is But we have something up here. No, that's probably not what we do. Connect it up like that, and then we see if we can fit this one in, and if we can't, we may even just about have enough space to make this one big, but that causes entanglements with the X-bus ports around here, so let's try not to. So then what this needs to do is I'm just wondering if I can stick a note somewhere down here that explains things. Probably not. Is so if we've been asked to retrieve, we need to first send that to the location coprocessor, then fetch from the location coprocessor and send to the movement processor where we that we want to fetch. Then we want to fetch from the location coprocessor. No, I don't. I'm doing this wrong. I think. Maybe I'm not. Let's keep writing for now. Then fetch from the location coprocessor the location we're interested in, send that straight to the mover. If on the other hand, and then jump back to the top. Now there is no way we can do the other version in this same space, so let's change this. And go instead still too many instructions. Yes. Well, I mean, I may actually have fitted that in, shockingly. So we first, that little loop at the top fetches, waits until we receive something useful from the radio. Oh damn, it's missing a slip 1, curses. Doesn't quite fit. So it's going to just spin there rather than doing something useful. And then it checks if what it received was a fetch or a receipt or a deposit, and then if it's a fetch, asks for an empty slot from the location processor, otherwise asks for the slot containing the thing we were interested in. Then asks the mover to move to execute. Well, we're missing the thing to actually tell the mover which move to execute as well. Oh, sod it. I'll try to work out the layout to put in a big processor here as well then. I need to change all the registers. This is a very expensive solution to this problem. One moment, let me finish writing this. Can you use 2 radios to solve a track routing problem? No, the game will not allow you to add extra radios. Or remove the radio you've got, I hope. No. Right. Well, that crashes immediately. Excellent. Technically it doesn't. We receive a signal. We receive 1. It's not minus 999, so we send it to there. We signal to the lookup processor that we want some information, want something. Well, that's the wrong place to send that to. That should be MOV X1 X0, right. Oh, that got somewhere. It successfully installed the first container in its correct location. And indeed the RAM tells us that it's installed that container in a different location. Excellent. That's because I didn't actually take advantage of having enlarged that chip to put in that extra instruction, which is MOV AC X3. Right. Oh, that looks pretty good. I did say it wasn't a very efficient solution.
Least efficient in power usage.
No, not the least efficient in production costs. Someone managed to fit more expensive components on the board somehow. Like, to be honest, it is getting quite... You could just about fit something else in there. That RAM, yes. It gets instructions written to it occasionally.
Oh, you can top. Okay. Right, okay. I just want things to the right going with options. Yes. I remember that.
So the point of that is essentially to buffer the commands from this thing to this thing, so that this one doesn't have to keep inserting complicated waiting instructions in between every single command it sends. So instead it writes 4 commands into this RAM, and then this one reads them out again shortly afterwards. But for extra confusion, they actually use the same. They're actually both connected to the RAM by the same track, and we just rely on them. Never trying to do it simultaneously. What thing? Oh, that's the aerial for the Wi-Fi. So yes,
I feel as if there ought to be some kind of secondary challenge for doing it as expensively as possible.
well, there is in a way.
I
mean, I can throw arbitrary devices in that aren't connected, of course. You know, I can increase the price by 5 yuan trivial.
Oh right, no, I mean actually using it for something sensible. So I play a completely unrelated game occasionally, in which you have to clear a screen full of mess by means of things flying into it that match the colours, and the screen is gradually closing in, so you have less and less room to manoeuvre. And they have a high score table where they score you on clearing the screen with the fewest moves. But I think there's also a challenge in surviving for the largest number of moves and not actually dying, because by the time you've only got like 2 rows left of this entire screen, it's a challenge to not have died and on the other hand still be on point, still be able to win.
So we have our emails. The great advantage, of course, no one actually cares that we made it incredibly expensive as long as it works. Oh, this is great! So satisfying to finally have the components we need for our food development projects ready when we need them, and without having to go into the freezer all the time. You're the best. Indeed, this is just what we need to make forward progress. I think we're getting close on the synthesized grains too. My dream of creating a full 7-course French dinner made from nothing but materials derived from kelp is within sight. This is going to be interesting, all right. So, Sung Hao Chan's Beyond the Clockwork, noted futurist Amber Posner's latest book, Beyond the Clockwork, is an important deep dive into the future of the human race. Specifically, what will humanity look like once we have essentially solved for our bodies? For almost all of recorded history, we've been overwhelmingly motivated by the most basic of impulses. But that era is coming to a close now, and Avalon City is at the forefront of that transformation. You're desperately trying to get food out of kelp at the moment. I'm not sure you are.
Once they succeed.
I won't spoil Amber's conclusions for you, but I will say this book has contributed materially to my thinking about where we go from here. So this is going to be a funny thing to ask for, but we need a handheld timer, because Derek has been using his phone for this, and phones are absolutely not sterile. They are the opposite of sterile. So the timer is to be nothing fancy, just something all the technicians can use to keep track of how long things ought to take. Wrapped in a hardened case, we can throw in an autoclave. It is 23:40, so, well, I mean, I'm thinking, how hard can it be? It's a very expensive divide by 2 counter.
That's good.
Isn't some of this the precision scale we had earlier? The on-off reset when 0 thing we've done already. But yes, it is 20 past 11, so I'm slightly tempted to go back to our prototype, Simon, and make it better.
The time in the game or in the real world?
In the real world, this is 23:42, according to at least one of my clocks.
Yes, okay. Not 20 past 11. Right.
20 to 12, yes. Was what I meant.
Some in-game
No,
time.
I was just misreading the time.
What do you mean? Is a time device?
Yes, possibly. Good night, Claire. So, now I need to work out how on earth I do this. I've given myself a challenge. So the thing is that the current system essentially handles making the lights light up by when you press the buttons, just by wiring the buttons straight to the lights, which is kind of cheating. Also, the current system cannot give the correct behaviour because it should go bong as soon as you press the wrong button. Forgot what the last button is. Rather than going bong shortly when you release the last button. And the reason why our current system waits for you to release the button is simply because it shouldn't start flashing all the lights again while you're still pressing the button, obviously. Remove those two unused instructions because I reckon we're going to need that space. So yes, that the low-level input processor at the moment sits sleeping, waiting for you to release the button. Now, I don't think so. I'm just also thinking idly about how to tidy things up so we can get some more space for more processors if we need them. In particular, we probably need some kind of sound processor eventually. So one thing I think we need to do is have this processor signal button down and button up events. Button up, it can just signal by sending 0. So I think it's actually a pretty simple change to this processor. The thing is that then the receiver has to do slightly different things. Which is obviously hard when it has no code space left. I mean, this processor only actually has 3 pins in use. So we could have this one wired up only by its left-hand pins, which would allow us to move it down a bit, which would be nice. Obviously this area can then be tidied up a bit. Sure that's right, but right. But mostly I'm fiddling because otherwise I have to work out what to do here. So this is the one that actually in its accumulator knows how many lights we're currently using, doesn't it? Because it's the thing that does the comparison of the button that we've pressed to the correct value. So it moves 2x. Then sends that to the RAM reading processor, then waits for the token, rather then hands over the token, waits for the token to come back, then asks the RAM reading processor to talk to it again, and then I'm having to remember how this thing works now. This is slow. So what's it talking to at that point? Yes, I think, or at least somewhat. So that's where it must fetch the current light that it's interested, that it wants to look for, and then if that's 0, then we go back, then we have reached the next thing. If it's otherwise, we wait for someone to press a button and then do something with it. So the problem is that if I have it respond to both button down and button up events, it has to have more. It has to do an entire SLX read cycle for the one that it only really cares about the timing of. Problem is, it really does want to know that which button has gone down when the button goes down, because it wants to go bong at that point, for instance, when the user's pressing buttons. Feels like there's more complexity here than I need, but so yes, that bit is signaling to this processor that it should play the lights out, and the problem is if we don't do that, it's like we have to multiply ACK by something big in order to sleep for that many and then tidy up the registers afterwards, and that's 3 instructions anyway. Feels like there's more complexity kicking around in here than I need. Like, we know from experience you can perfectly well have two things reading the same port on the RAM. Can we use that fact to our advantage? So because what we have here, there seems to be an awful lot of complexity in this design, Ben. Like, I'm kind of going, what does this processor even do? Like, it signal, it oh, I didn't mention what I discovered happens when you win the game, did I? Well, let's have that for the record. It turns out that when you reach round 32, if you win round 32, which is easy to fake by making the first round 32 and then reading the values out of the RAM by eye. It then tries to give you round 33, but it never finishes playing round 33 because the RAM address pointer never reaches 33 because it wraps round from 32 to 0. And so it just essentially flashes the entire sequence of 32 lights plus the 33rd one you never even guessed forever, which I think is a reasonably acceptable way to handle wins for now. So anyway, where were we? Yes, I was going, why does this processor even? So, like, it's got the reset logic there. It's the one that handles counting things out of RAM. And it essentially converts the counted strings into zero terminated strings. Which means that neither of these processors needs to use its no, but you don't use the accumulator anyway. Needs to read the address pin needs to have its accumulator contain where we're going to. But like this one only uses the accumulator for things you could use DAT for. This one already has the target number in the accumulator. So it kind of feels to me as if this processor, currently its only job is that it signals back to this one to reset everything, and it signals a bong to the sound card. And while obviously those jobs need doing, like we already have essentially the fall through here handles them. So what's this bit doing then? It reads in from that processor. If it gets a 0, under what circumstances would it get a 0? I mean, obviously, whoops. There is a MOV null X1 there. Don't really understand what this processor does anymore. It's so long since I've set it up. I mean, I haven't made much progress here, have I? I've slightly squished things down into that corner, and I'm kind of getting the feeling we don't need anything like the amount of complexity that this processor has. So if we didn't have that complexity, what would we have to do instead? We would have to have other processors directly reading the RAM, which would mean that something would need to be able to write and read the address pins. And the alternative is we try to move more into this processor to make it more intelligent. So like it could have different X-bus ports that it uses for writing to input and output processors. Would that be helpful? That would simplify I mean, at the moment it just feels there's an awful lot of code in here that's doing not very much good. And that we could do better. By having the other processors like closer to the RAM. Logically. rather than having this one. And this one does the counting, kind of. But it could instead just signal this thing to play out in lights, and then signal this thing to read in button presses, comparing them against the RAM, and then we could have something that handles the failure. So what would be the big difference then? Would that simplify this one's code any? I mean, it still needs the system that waits for a button press, that waits for a signal to say accept button presses, then waits for button presses, and loops. Well, it's midnight and I've made zero progress here. Well, almost zero progress. Because I'm still trying to work out what's going on, really. And whether we've got things in the right place. Oh well. We'll come back to it on Sunday after I've done the timer task, and we'll see if we can do better with slightly more time. I may possibly sneakily stare at it over the weekend. Make sure I have an idea of what all the code's for in my head by Sunday. So yes, anyway, I think that is enough for tonight. So I shall be going to bed in case anyone's still listening, and we will see you on Sunday.